This is SpaceTime, Series 28, Episode 131, for broadcast on the 7th of November 2025. Coming up on SpaceTime, the detection of phosphine in the brown dwarf atmosphere raising questions, a new hypothesis to explain how some planets get their water, and preparing for our return to the surface of the Moon. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
Astronomers have for the first time discovered phosphine in the atmosphere of the brown dwarf Wolf 1130c. Phosphorus is one of the 6 key elements necessary for life on Earth. And when combined with hydrogen, phosphorus forms the molecule phosphine, an explosive highly toxic gas. But the new discovery reported in the journal Science raises questions about why this elusive gas isn't more prevalent in other brown dwarfs studied. Brown dwarfs are failed stars, objects which don't have enough mass to sustain the core hydrogen fusion process which makes stars like our Sun shine. However, some brown dwarfs do fuse deuterium or lithium under certain conditions. While many brown dwarfs are born as such, others start their lives as spectral type M red dwarf stars, which have lost most of their mass during their evolution, thereby ceasing core fusion and turning them from red dwarfs into brown dwarfs. Brown dwarfs fit in a category between the largest planets, which have about 13 times the mass of Jupiter, and the smallest spectral type M red dwarf stars, which are about 75 to 80 times the mass of Jupiter, or about 0.08 solar masses. The Wolf 1130 ABC star system is located some 54 light-years away in the constellation of Cygnus the Swan. The brown dwarf, Wolf 1130c, follows a wide orbit around a tight double star system, composed of a red dwarf star, Wolf 1130a, and a more massive white dwarf, Wolf 1130b. Wolf 1130c has been a popular source for brown dwarf astronomers due to its low abundance of metals compared to the Sun. Astronomers call all elements other than hydrogen and helium metals. Phosphine had previously been detected in the atmospheres of the gas giants Jupiter and Saturn, and it's long been recognized as a possible biosignature for anaerobic life. That's because there are few natural sources of this gas in the atmospheres of terrestrial rocky planets, like the Earth. In fact, on Earth, phosphine is a byproduct of decaying organic swamp matter. Phosphine was detected in the atmosphere of Wolf 1130c using observations obtained by the Webb Space Telescope, the first telescope with the sensitivity to look at these celestial objects in detail. The mystery, however, is not why phosphine was found, but why it's missing in other brown dwarfs and gas giant exoplanet atmospheres. The study's lead author, Adam Burgasser from the University of California, San Diego, says understanding this problem with phosphine is one of his team's first goals. In the hydrogen-rich atmospheres of gas giant planets like Saturn and Jupiter, phosphine forms naturally. As such, scientists have long predicted that phosphine should also be present in the atmospheres of gas giants orbiting other stars and in their more massive cousins, brown dwarfs. Yet phosphine has largely eluded detection, even prior to the Webb observations. And that suggests problems with science's understanding of phosphorus chemistry. Prior to Webb, phosphine was expected to be abundant in exoplanet and brown dwarf atmospheres, following theoretical predictions based on the turbulent mixing that occurs in these bodies. But every observation obtained with Webb challenged this theoretical prediction. That was until Wolf 1130c. Unlike other brown dwarfs, Burgasser and colleagues easily spotted phosphine in Wolf 1130c's infrared spectral data. To fully understand the implications of their findings, the authors needed to quantify the abundances of this gas in the brown dwarf's atmosphere. The authors used a modelling technique known as atmospheric retrievals. This uses the Webb data to determine how much of each molecular gas species should be in the atmosphere. The models showed that abundant phosphine was in Wolf 1130c at the predicted theoretical abundances of about 100 parts per billion. But it raises an issue. Why is phosphine present in the atmosphere of this specific brown dwarf and not others? One possibility is the low abundance of metals in Wolf 1130c's atmosphere, which may change its underlying chemistry. It may be that under normal conditions, phosphorus is bound up in other molecules such as phosphorus trioxide. But in the metal-depleted atmosphere of Wolf 1130c, there isn't enough oxygen to take up the phosphorus, allowing phosphine to form from the abundant hydrogen instead. Another possibility is that the phosphorus was generated locally in the Wolf 1130 ABC system, specifically by its white dwarf binary Wolf 1130b. A white dwarf is the leftover core of a sun-like star that's finished fusing hydrogen. They're so dense that when they accrete material on their surface, they can undergo runaway nuclear reactions, which astronomers detect as novae. While astronomers haven't seen any evidence of such events in the Wolf 1130 ABC system in recent history, novae typically have outburst cycles which could be thousands to tens of thousands of years long. And this system has only been known for just over a century, and so early unseen outbursts could have left a legacy of phosphorus pollution. Earlier studies have proposed that a significant fraction of phosphorus in the Milky Way could have been synthesized by this very process. Understanding why this one brown dwarf shows such a clear signature for phosphine may lead to new insights into the synthesis of phosphorus in the Milky Way and its chemistry in planetary atmospheres. This is SpaceTime. Still to come, a new hypothesis to explain how some planets get their water, and preparing for our return of humans to the moon. All that and more still to come on SpaceTime. A new study claims that some planets may produce water during their formation through reactions between their rocks and hydrogen under pressure. The findings, reported in the journal Nature, offer new insights into why some exoplanets have water on their surfaces. The presence of water is a key ingredient in determining a planet's habitability. And water has been thought to form through condensation from space, as ice or snow at low temperatures. This process has typically been observed in exoplanets between the size of Earth and Neptune, which are located far away from their host stars. However, NASA's Kepler mission has found exoplanets between the sizes of Earth and Neptune with liquid water that orbits close to their host stars, calling this process into question. The new hypothesis follows laboratory experiments using pulsed lasers and high pressure to heat rock samples. The authors found that hydrogen reacted with melted silicates from the rocks, releasing oxygen that bonded with leftover hydrogen to form water. This reaction could occur in the high-pressure, high-temperature core envelope boundary of exoplanets larger than Earth, places where the denser, rocky core meets an outer envelope of gaseous elements over billions of years. However, the speed of these reactions is determined by how much hydrogen is available and how hot the core envelope boundary would be. This is SpaceTime. Still to come, preparing for humanity's return to the surface of the moon, and later in the science report, a new way to make chocolate taste even better. All that and more still to come on SpaceTime. More than half a century ago, humans stepped onto the moon for the first time in a set of sorties that awed the world. And now they're finally preparing to go back. NASA's Artemis 2 mission will send a crew of 4 around the moon in April next year, although that could take place as soon as February. And that will hopefully be followed by Artemis 3, which will land people at the lunar South Pole in 2027. Over the years since those first Apollo missions, astronomers have explored our solar system with robotic scouts and established a permanent human presence in space with the International Space Station. Now, Earth's space agencies are looking to return to the moon at a very different landing location from where the Apollo missions touched down more than half a century ago, the lunar South Pole Aitken Basin. See, the 5 Apollo missions all landed in areas that corresponded roughly with the darker spots visible on the lunar surface. The samples of lunar rocks the astronauts brought back to Earth are still being investigated and analysed by researchers all over the world, and new discoveries are being made as lab techniques improve to advance science's understanding of the moon's creation and evolution. NASA, the European Space Agency, and the Chinese are targeting the moon's southern regions because it's thought to be an area which contains more water than any other region on the lunar surface. Water is important because it can be broken down into hydrogen and oxygen, used for breathing and drinking, but also as a rocket propellant. This report from ESA TV.
The European Space Agency is working to take humans beyond low Earth orbit and deeper into the cosmos. Our next destination on this journey is the Moon. The 1960s and 70s were an incredible era for space exploration. The Ranger missions from the United States took close-up images of the Moon before eventually impacting the surface. NASA's Surveyor missions demonstrated a controlled, soft landing at the surface of the Moon and tested the properties of lunar soil to prepare for future human missions. A series of Soviet landers and rovers visited a number of locations, performing scientific investigations, driving across the surface and returning samples to Earth. But the pinnacle of this period of exploration was Apollo, and the arrival of humans at the surface of another solar system body for the first and only time in history. Looking back now, though, we see that only a tiny fraction of the Moon's surface has been explored, all on the side of the Moon that faces the Earth and in a region close to the equator. We've also discovered that all of the samples we have returned to Earth are from an unusual region with a complex and exotic chemistry of potassium, phosphor, and rare earth elements such as thorium. The vast majority of the Moon has yet to be explored, including the entire far side. One thing that we can say for certain is that if we want to understand the Moon, then we need to go back there. Now, after decades of waiting, an armada of missions from around the world have returned to explore the Moon from orbit. Looking down from above, these missions are providing a wealth of new data, bringing a new understanding and raising new questions. They are giving us a global insight. The next destination will be the extreme and alien landscape of the lunar South Pole. Here, we find areas of permanent darkness and extreme cold, where water, ice and other chemicals can become trapped. And as we come up from these lowlands, we see towering peaks, basking in near constant light. On these polar mountains, the sun rarely sets below the horizon, providing the potential for near continuous solar power and a spectacular view over the rugged and cratered landscape below. In 2009, the L-Cross mission blasted water and other chemicals out of a permanently dark crater in the South Polar region, allowing it to be observed by nearby spacecraft for the very first time. We also now know that there are nearby locations with similar cold conditions. Is there water here too? If so, how much is there? Where did it come from? And what can it teach us about the origins of water and life-forming chemistry on Earth? This water may have been delivered by comets and asteroids impacting into the surface over billions of years. It may even have been created at the surface of the Moon. We now know that protons thrown out by the Sun in the solar wind arrive at the lunar surface. Here, they react with oxygen in minerals to create a thin layer of water. These water molecules can be lifted by the Sun's heat before falling again to the surface. Over time, these particles may move to the polar regions, where they're trapped by the cold conditions. And as we stand at the pole, with the Earth in view, we can point our antennas to the sky to search for faint signals from deep out in space. But radio noise from the Earth is too loud and blocks out many cosmic radio sources. But as we move over the horizon, the Earth sets out of view. The noise disappears and a new kind of radio sky emerges. We see our galaxy and the planets as never before. And beyond, a quiet radio hum, a signal from the cosmic dark ages more than 13 billion years ago, when the first cosmic structures were formed. Formed by a powerful impact around 4 billion years ago, the South Pole Aitken Basin. Many believe that its formation marks the start of a dramatic period of bombardment onto the Earth and the Moon, an era called the Cataclysm. This era is recorded on the Moon's scarred surface, and its end coincides with the appearance of the earliest observed traces of life on Earth. In the coming years, we will see explorers at the lunar poles, exploiting the extended sunlight for power and performing research to benefit life on Earth and to understand our place in the universe. This will begin with small robotic missions to understand the environment and prove new technologies to pave the way for the future. We will then move on to increasingly ambitious missions with humans and robots working together, learning to live and work at the surface and performing new and important scientific research. Eventually, we will see a sustained infrastructure for research and exploration. where humans will live and work for prolonged periods. Here, we will put into practice the lessons of years on the International Space Station to establish a facility akin to those that we see in Antarctica today, a place where we can learn to move onwards into the solar system. And perhaps in the future, at a sun-bathed peak at the lunar South Pole, at the edge of a crater, we will learn to access and utilize resources from deep below in the dark. Water, ice, molecules trapped in the cold, a source of hydrogen and oxygen essential for sustaining human life and for rocket fuel to propel us further into the solar system and on to the next destination of our journey into the cosmos.
This is SpaceTime. And time now to take another brief look at some of the other stories making news in science this week with a science report. A new study has shown that teens who start using cannabis before the age of 15 and continue to use it frequently during their teen years are more likely to need medical care for both mental and physical health problems well into their early adulthood. The findings, reported in the Journal of the American Medical Association, compared health records of 1,591 teens who were surveyed at ages 12, 13, 15 and 17 about their cannabis use in order to see what care they needed for mental disorders and physical health problems until they turned 23. Compared to teens who reported no cannabis use, the authors found that early and frequent cannabis users had 51% higher odds of seeking care for a mental disorder and 86% higher odds of seeking care for a physical problem. Teenagers who started using cannabis after the age of 15 did not see the same mental health risks, but they still had increased physical health risks compared to non-users. A new study warns that the world's major electric car manufacturers will need to rely on lithium imports as soon as 2029, even if their countries start digging up as much of the metal as they can. A study in the journal Cell Report Sustainability says that to stop this lithium shortfall threatening the world's climate goals and straining international trade relations, manufacturers need to start using low and non-lithium batteries, or governments need to shift their focus from EVs to public transport. Australia is one of the few exporters of lithium which is used to make EV batteries, making it as important today as gasoline was during the Industrial Revolution. We all know that some chocolates taste better than others simply because of where their cocoa beans are grown. Now, scientists have figured out how to recreate the same taste in the lab. A report in the journal Nature Microbiology claims the difference in chocolate quality is due to the types of microorganisms involved in the natural fermentation process of cocoa beans, with some farms simply developing better microbial communities. Performing DNA sequencing analyses of fermenting cocoa beans from 3 Colombian farms suggests the best tasting chocolate came from one of them which had a unique microbial community. Designing their own microbial community in the lab has now allowed scientists to reproduce that fine chocolate flavour when sampled by professional tasters. It's been claimed that the late Queen Elizabeth II may have sanctioned an exorcism to banish a ghost from Sandringham Estate thought to be that of Princess Diana. But Tim Mendham from Australian Skeptic says the whole thing sounds pretty sus, and if there was any truth to the claim, it's more likely to have been a cleansing rather than an exorcism.
Two aspects to the story you start off with. One, royal family not exactly known to be at the cutting edge of science discoveries and things, so that's the one issue. Two, we assume it actually happened as it has been reported, but we don't know that for sure. Story goes that some time ago, the Queen organised for a, quote, exorcism, close quote, of Sandringham House, where a ghost was appearing or emanating, or whatever you like to say, scaring the staff and perhaps other people. Now, people jumped to the assumption that that was Princess Diana's ghost, and that the royal family at the time would be very happy to get rid of every trace of it. But what actually happens, if it happened, was that it wasn't an exorcism with a priest splashing water around and people wailing and spinning their heads around, etc.
The power of Christ compels you!
It was basically what you might call a cleansing, where they have a clergyman comes in and goes, "Begone, ghosts, clean this place out," and that's about it. So suggesting it's the Queen sitting down with her Ouija board and the crystal ball and ectoplasm going everywhere, etc., might be a tad clickbait for this story. But it's interesting. It's also suggested, by the way, that it wasn't for the Queen. She didn't care that much, apparently, according to some versions. It was mainly for the staff who were a bit scared, so they did something to make them feel better. Whether there was a ghost, whether that even cleared the ghost, did it make the staff feel better? Probably. And it was a little ceremony like that, actually, which you could almost have an afternoon tea with it. So no one spitting bile anywhere, no one sort of calling out the devil and all that sort of stuff, throwing the crucifix on people, etc. No, nothing like that at all.
The royal family do have a bit of a history when it comes to this sort of thing. I believe crop circles were once a big thing.
Crop circles, UFOs, obviously homeopathy, that debunked form of quote medicine, unquote. So, yeah, there are various areas where apart from Prince Charles, as he was then talking to plants, supposedly, there is history there of royal family, same as any family really, believing in a lot of strange things. Does not make them true, although it's interesting that people use them as an authority, and I don't know why. It's like using a film star as an authority, a scientific expert, etc. Why the royal family?
Why would you accept a celebrity as having some sort of divine knowledge of anything?
Because they're celebrities. You go ask Joe Blow, the assistant butcher down at your local shop, you ask him, what's your view of the world situation on spiritualism? You probably might not believe him.
Yeah, but Joe Blow down at the butcher shop probably has a better grasp on reality than your average Hollywood movie star.
Quite possibly, actually, yes. Especially as movie stars tend to pretend to be someone else. That's what they rely on. I don't know. Why a movie star? Why a royal rather than a politician or something? Actually, politicians, a lot of them believe it is too.
Politician's not a good example, no.
No, probably not the best example. But, I mean, it is this issue that, one, you mention royal family and sort of pseudoscience or the paranormal, people get excited. Then you look at the reality of the story, in this case, assuming it's true, and it's pretty low-key. It's nothing particularly special. It's what a lot of people might do in any case just to make people feel better.
That's Tim Mendham from Australian Skeptics. And that's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Bytes.com, SoundCloud, YouTube, your favourite podcast download provider, and from spacetimewithstuartgary.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies, or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to spacetimewithstuartgary.com for full details.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.